So this is an overview of a much less, and I can now come back to the original document, I guess, of a less formal business requirement description. But still, I can evolve this document and bring it up to the level of a functional spec by adding a use case diagram to it and by adding detailed description of use cases, right? So we saw examples of use cases. Now in this project, in this semester project, where I want you to develop an idea, come up with formal functional spec, and then also create a class diagram showing the structure of classes inside, and then also make a presentation. In this entire semester project, I am not focusing on a very formal set or format describing those use cases. Some people could use just paragraphs describing what they are. I am not asking you to come up with every single situation describing those use cases in detail and everything that's involved. I'm not going to focus specifically on use cases. However, the use case work is extremely important. In the real application, use case documentation is by far the most important piece that you can have. It needs to be as accurate as possible. It needs to be verified by many people. It needs to be reliable. It needs to be written with clear, clear language, with all these, glossaries of terms and dictionaries, and everything needs to be preserved and written very cleanly. However, in this particular project, I'm not making big emphasis on use cases because we'll have a chance to do this in the next year, a year from now. In CIS 260, we're actually going to redo this on a larger scale and actually write code for a number of use cases. So that's going to be for the future. At this point, I'm primarily focusing on you developing an idea, writing an example of a requirements document, which includes functional specs, coming up with an example of a structural design, translated UML class diagram with some classes there. We'll have a chance to discuss this in the future as well. And also make a presentation, essentially show it and say, okay, that's my idea, this is what I was thinking about, or as a group, you can discuss it as a group and show examples of those class diagrams and basically present this part of design. Okay. All right. So what else? Let's take a look. What else we can talk about today? Let's finish an overview of this semester end document. So this is where I'm summarizing those deliverables, right? So it would be useful to choose a nickname for your project, like an application name, right? So some sort of a nickname. It's easier to refer to it when you're making a presentation, when you have a name or nickname for it. For instance, as an example, when Microsoft designs a new version of Windows, they usually give it a nickname, and you can research that. The team member names, individual responsibilities. So business requirements specification, which includes functional requirements. Software analysis model is the UML diagram, and design presentation outline, so that I don't want you to go into the presentation without any sort of an outline. So I'm asking you to basically submit as a final part here is some sort of an outline, so it's readable, so I can see what is your plan, what you're planning to talk about when you make your presentation. All right, formal design and development. So most commercial systems cannot be built without a formal design, and again, this will be discussed a lot in our class. Software development process has 3 stages. and they're actually iterative stages. Analysis is pretty much what we were doing here all day today. Rotating this discussion around functional spec, talking about use cases, talking about potential candidates for classes, if you're more on the software side. If you're a power user or expert user in the field, you're basically thinking about the business rules, the constraints that exist, government regulations, state regulations, and things of that nature. You may also think about the security of it as well. So the design is that when we gathered all this information already, and we pretty much have clear idea what the use cases should be in the system, then we begin to identify conceptual parts of this description, and they will become software classes, right? So such that we already discussed here, specific to time slots and schedules and employees, and perhaps a class that represents a certain type of user. There could be classes representing reports or database tables or database queries. All of those useful concepts will most likely become classes when the software is written in the using object-oriented approach. And implementation is, of course, writing and testing the code. Even as a programmer, you really don't write code. You write code and you want to test it. But of course, there is much more formal approach to quality assurance of the software, and there's more to it than just informally, writing code, be able to compile it, and do some basic testing with it. In addition, there is a separate stages of it. But again, focusing on our own world right here, we just want to say that we just want to focus on these three main categories of the evolution of the software, that we do some analysis, and the result of it is the business requirement documentation. We do some design, and the result of it is a series of UML diagrams which show the user interface, would also show use cases, would also show class diagrams, activity diagrams, sequence diagrams. There's a number of diagrams that could be produced. In our project, we're focusing primarily on class diagrams. In implementation, we don't even touch, but we'd like to see implementation in view, because after all, the purpose of doing all of this is that at some point an actual code can be written, right, for your design. So describing business requirements, we talked about this already, and we'll do again those exercises. Today I did a little bit of this, is basically saying that when you have a requirement specification complete, oftentimes different nouns could be representing excuse me, classes of objects, and verbs often denote operations or methods that the objects can carry out, the different tasks. Right, so let's preserve this.